So in
Yes.
in the example shown, there are 6 links and 7 parts, correct?
6 links and how many pairs? P is number of pairs. How many pairs are there?
7 pairs are there, no?
See, if I count, so if I count the pair, first pair, okay, you count it. I will list it. Okay, link one, link four, one pair. Okay, count. Okay, then link one is also connected to link two at point B. So it is second pair. Link one, link two. Then link one, link five. It is third pair. Okay. Then moving forward, link 5 is connected to link 6, fourth pair. Link 6 is connected to link 2 at point G. Okay. कितना हुआ pair?
5.
5. Then your link 2, this link 2 is also connected to link 3 at this point. Total 6 pair. And link 3 is also connected to link 4 at point D. So total 7 pairs. 2 into 7, 4. 4 minus 4, 2 into 7, 14. Minus 4, 10. Okay, and on left hand side, number of links. So how many links are there? 6 links. Okay, where we are getting wrong. Just a second. So let us count. 1 and 4. Link 1 and link 4. ये हमारा एक काइनेमेटिक पेयर है. Then 1 is also connected to 2. Link 2 is one kinematic pair. 1 is also connected to link 5. Then link 2, link 5 is connected to link 6. It is 5, 6. Then here link 2 and 6 are connected here. Two, 6. Then link 2 and link 3 is connected here. So 2, 3 and link 3 and link 4 is connected, right? Okay, so here we are getting 1, 4 is correct, 1, 2 is correct, 1, 5 is correct, 1, 5, 6. Yes, correct. Then 2, 6 correct, 2, 3 correct, 3, 4. So 2 into 7 number of pairs. 2 into 7 is 14. 2 into 7, 14 minus 2p minus 4. 2p minus 4 means you are getting 10 here. So what is means here left hand side is coming as greater. Left hand side is 6 is less compared to right hand side.
Yes, sir.
Mm. Yes. Links are okay. Let us keep it for the next lecture. Okay, I will explain you that how it is coming. Okay, we will keep it. We will solve it in next lecture. Okay, so let us move to the next topic. I will explain it to you next lecture. Okay. Next is your types of joints in a kinematic chain. Okay. So you know, depending on uh, whether at one joint, at one point joint, okay, how many links are connected. Depending on that, that joint is classified as binary joint, then ternary joint, and then quaternary joint. Okay. So what is a binary joint? When two links are joined at the same connection, the joint is known as binary joint. Okay. So here you can see in this particular thing, there are say how many links are there? 11 links are there. Okay. And these 11 links are connected with each other at some point. So if you see this particular point D, okay, I can find only one. At point D, only two links are connected. That is link 4 and link 5. So I will call D as a binary joint, right? Okay. Now, what is ternary joint then? In at ternary joint, at ternary connection, okay, three links are connected at same connection at same point. Okay, so if you can find ternary joint in this, so here at point A, uh, three links, link 1, link 3, and link 11 are connected. So I will say that it is a ternary joint. Okay, then again point B is there, or any other point is there. Point B is also a ternary joint where link 1, 2, and 4 is connected. Okay, then what about the quaternary joint then, where four links are connected? Okay, so four links, you can say that this point, point G is your quaternary joint. So how many links are there? 7, 8, 10, and 11. All are connected at this point. Okay, so according to the number of links, they have been designated as binary, ternary, and quaternary joint. Okay, so suppose if you are counting the joint, say if you are counting the joint, okay, so generally what happens, that binary joint is considered as single joint. Okay, but when you consider the ternary joint, then what we do in counting, we count two binary joint, means one ternary joint is equivalent to two binary joint. Similarly, when we count the quaternary joint, okay, so we consider that one quaternary joint is equivalent to three binary joint. Okay, because we have to use this equation. Okay, and in this equation, what is J? J is your number of binary joints in the given kinematic chain. Okay, so by using this equation, uh, you can decide whether a particular assembly is a kinematic chain or something else. Okay, so here you can see that here H term is also there. It is added. So why H is added? So H is what? H is the number of higher joint or number of higher pair. Okay, in the kinematic chain. For example, if any mechanism is there, and in that mechanism cam and follower is there, so cam and follower comes under higher pair or higher joint. Okay, so if in any mechanism cam and follower is also there and they are in touch with each other, so whatever joint is formed between these two, we will consider that it is a higher joint. Okay, and we will say that in that mechanism there is one higher joint, so number of higher joint will be 1, and accordingly you have to use this equation. Okay, if suppose number of higher joints is 0, then this equation will reduce to this form, which we have already seen. Okay, so generally whatever mechanism is given to you, the higher joint mechanism is not given to you generally. Okay, so this equation is applicable to most of the kinematic chains. Okay, have you understood it?
So there are 7 joints in this figure, correct?
Let me count. 1, 2, 3, 4, 5, 6, 7. Right, correct.
And 11 links.
11 links, right.
So again, LHS is not equal to RHS.
So it is not a, what we say, that it is not a kinematic chain then, right? It
Okay,
is
sir.
not a kinematic chain because it, so see, if you will try to move one link, then other links will not turn. For example, suppose I fix this link 1 here. Link 1 is fixed, link 1 is grounded. Okay, now what I do, suppose I want to turn the link 3. So when you will turn the link 3, you can see that it will not turn because it is also connected to the link 2, which is also connected to the fixed joint. Okay, just for example, uh, if you can join the 3 pins. Okay, or you can do this, and if you try to turn one link with respect to another link, then it has to get out of this connection. इन दोनों का connection lose हो जाएगा 3 and 2 का, and there is one connection, means relative motion is not possible. So it is not a kinematic chain. It may be considered a structure, right? Means no relative motion
Okay, sir.
possible. No relative motion possible between the any two links. Okay, so that's about it. Then I will go to the next. Okay, so then let us see what is mechanism. Now let us mechanism we have seen. Okay, now what is the proper definition? So first we defined, kinematic link, then kinematic pair, then kinematic chain. Okay. Now what is mechanism? How you obtain the mechanism from kinematic chain? That when one of the links of a kinematic chain is fixed. Okay, fixed means you have to make it stationary. Okay, with reference to ground. Okay, means every other link will turn, and that fixed link will not turn or will not slide. No movement is possible because you have fixed it to the ground. or okay, or some table or some reference which is again connected to the ground, or you have fixed that link to the wall, because wall is also a fixed thing. Okay, so you have to fix one of the links of the kinematic chain to make it a mechanism. Okay, and a mechanism may be used for transmitting or transforming motion. For example, engine indicators, typewriters, and all other mechanisms like IC engines you have seen. So in IC engines, okay, which link is fixed? How many links are there in IC engine? Mainly there is engine frame, okay, which also holds the cylinder, engine the cylinder. Then in that engine the cylinder, piston slides. After piston slides, there is connecting rod. Then there is crank. So out of all these different links of the IC engine like cylinder, piston, connecting rod and crank, which one is fixed? Which link is fixed? Is piston fixed? Piston fixed होता है क्या?
No, sir.
No. Connecting rod?
No, sir.
No. Cylinder fixed होता है?
Yes, sir.
Yes. So you have to fix any one link in order to make a useful mechanism out of the kinematic chain. Okay. And when a mechanism is required to transmit power, or to do some particular type of work where energy is used, energy is utilized, then it becomes a machine. Okay. So there is no much difference between mechanism and machine. Okay. Mechanism mainly modifies the motion. Okay. And machine either modifies the energy or transmit the forces. Okay. Next, okay. So next topic is a little derivation. We will start. We will cover it in the next lecture, right? Okay. Then our CR is there. Our CR. Oh, Uditang, but but Bhattacharya. He is not in participants. Okay, no problem. Then we will continue in next class. Okay. Any doubt you can ask. Otherwise, you can leave. Bhattacharya, I can't hear you, but I can see your chat.
Hello?
Yes, but see, I think I will be
Sir, your
messaging you.
voice is breaking.
Breaking. Okay. Okay, so I will contact you.
Hello.
Okay? I will contact you. Okay, you can leave now.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.